All right, so we're in chapter 3.9 and we're going to be doing an example of work. We want to know what is the work required here to pump this oil out the top. There's a little hole in the tippy top of this tank. Okay, we're required to pump all that oil out. Okay, so some of the parameters for this problem are we have a spherical tank, okay, with a radius equal to 8. We're going to assume it's centered at the origin, okay, which gives us a total height of the tank of 16. We're told that the tank is half full, which means our oil only goes up to 8 feet, okay? Now, our radius at the equator is equal to 8. I call it the equator on a sphere. That's our widest spot, okay? The total top of the tank is 16, right? And it's filled up halfway. We're given the weight of the oil, basically the weight density, which is 50 pounds per cubic foot. So when we go to think about doing the work, we have to think about the force, the delta force, that's going to be required to do this. So this is going to be thought of as our weight. This is our weight density. So this is 50 pounds per square foot, for cubic foot, times, and I have to multiply that by the volume. Okay, this is in cubic feet, so that's going to give me my weight, which is in 50 pounds, or just in pounds, units. Okay, so now let's think about this. 50. Okay, now my volume, right, for a sphere is pi r cubed, okay, but my radius is going to be changing. So first thing I think about pi x squared times delta y, okay, and this is going to end up being in pounds, okay. This x squared times y is going to give me a cubic unit, okay, that's going to be equivalent of that. So now to calculate the radius, right, we've talked about the radius of our sphere at the widest part is equal to 8 feet. But the radius at the bottom isn't 8 feet. The radius here, right? We're going to be cutting this sphere into tiny little slivers of circles, right? And each circle is going to have a different radius depending on where we are within that sphere. So I need to be able to think about how I'm going to calculate that. So let's see, our center, each of those circles, let's talk about that. My center of my widest circle is at 0, 8. So I'm going to come up with an equation. So my circle is x minus 0 squared plus y minus 8 squared equals our radius squared. Okay, this is the equation of a circle, which is our cross-sectional area right here at the center of our sphere. Okay, now, right, I said that my radius, my x, is going to be changing as I go. Because I'm lifting this up at the top, I'm going to be doing this in terms of y, right? So I want to solve this. X squared equals, I'm going to say 8 squared, so 64 minus y minus 8 quantity squared. Okay, and that's going to be able to give that to me. When I multiply all of these things out and then solve, my x squared is going to equal 16y minus y squared. This x squared here is what I'm going to plug in for that part right there. Okay, and it's going to give me an equation of my radius as a function of where I'm at in my y direction. Okay, so let's go back. So my delta F now is going to be equal to 50 times pi, right, that comes from a pi r squared, times our radius squared, x squared, 16y minus y squared, times our delta y, right? This is our delta y, these tiny little slivers. That'll become dy when we go to integrate it. Okay, now we have to think about the distance that we're going, right? So if my height is 16, right, I'm going to raise this water here. Down at the bottom, I'm going to raise it the full distance. But the oil that's here, I'm not going to be raising that the full 16 feet. So I have to think about what I'm actually doing for my height, which I'm going to take my total height, 16, minus y. And that tells me what distance that we're traveling, okay, that we're actually doing the work on, okay? So let's put it all together. This is the distance that we're going. Okay, so let's plug it all in here. Next thing you get 50 pi times 16y minus y squared times 16 minus y. And this is going to be ultimately times delta y, which will become dy later. So now when I multiply all that out, so my work, I'm going to integrate. When I integrate, my bounds of integration are how much oil am I actually doing? This is the volume of oil I'm doing. I go from 0 to 8 because we're told that the tank is half full. Tank is 16 feet in diameter. Half full means I'm going from 0 to 8. That's the volume of oil that I'm taking out. So I'm going to put all of this stuff together here. 50 pi. Now I multiplied all of these things through to get 256y minus 32y squared plus y cubed dy. And when I integrate it, I'm going to get 50 pi 128 y squared minus 32 over 3 y cubed plus y over 4 over 4. And I'm going to integrate from 0 to 8. When I plug in everything, I'm going to get roughly, let's see, 50 pi times 11,264 divided by 3, which is approximately, when I multiply through by pi, like 589,782 foot-pounds.